Hello everyone, welcome to my channel. My name is Rishabh and today we will be going to discuss about content-based image retrieval. In this project, we will continue the process of learning how to manipulate and analyze images at their pixel level. This is the project where we will begin to learn about image matching or pattern recognition. The overall task of this project is we have been given a database of images and a target image, and we have to find in the database which has the similar content. Let me tell you what I am trying to say. Let's suppose this is my database of image. So we can take any one image as our target image and we have to find which other image in the database has the same features like this one. Okay, let's suppose this is my target image. Okay, now if I see this image is very much similar in color or in texture with my target image. So this image would be one of my answer, one of my top n match. This image, this second image also will be my one of my top n match, or this image can be, or this image. Okay, so this is basically the gist of what we have to see, what we have to do in this project. For this project, we will not be using any kind of neural networks or any object recognition method. Instead, we will focus on more generic characteristic of the image, such as their color or their texture or their any spatial layout. Okay, I have implemented this project into two parts. Okay, the first one is feature extractor and the second one is image retriever part. Okay, in feature extractor part, I basically open the database file, and for each image in the database, I first read that image and then I compute the feature vector from that image, and then I store that feature vector from the image into the database. Okay, and in the image retriever, I basically read the target image. After that, I compute feature vector of the target image. Then I read the database file of the image feature vector. After that, for each entry in the database, first I compute the distance between target and feature vector in the database, and second I store the distance and the entry ID. After that, all the distance that I have got, I will sort that distance in ascending order, and then I will print the top n entries. I will be doing this using two distance metric. The first one will be my sum of square distance. This will be my first distance metric. Okay, and histogram intersection will be my second distance metric. Distance metrics, they are basically used to quantify the dissimilarity or similarity between two feature vectors. Here, the first one, the sum of square distance, it measures the overall difference between the vectors, and the smaller the value of sum of square distance, the more similar the vector will be. Okay, and for histogram intersection, it will calculate the sum of minimum values between corresponding elements of the vector. This metric will basically measure the overlapping or we can say intersection between the histogram represented by the vectors. The more higher value, it will indicate a higher degree of similarity between the vectors. Okay, here we have to perform 5 tasks. The first one is baseline matching, second one is histogram, and third one is multi-histogram, fourth one is texture and color. After that, we have to perform like Gabor texture and color, then mid Gabor texture and color. Okay, let's see how I have implemented all those features. Right, the first one is baseline matching. Yeah, here it is. Okay, so baseline matching, it basically refers to very simple and very straightforward approach to image matching or a similarity comparison. In the context of this given task, okay, here the baseline matching method involves using a very specific region in the image. Okay, the feature vector, it represents the essential characteristics or the attribute of the image. Let me show you here. Here, if we see this photo, this picture, in the middle it is of red color. The second picture also, in the middle it is of red color. In the third picture also, and in the fourth picture. That's why they are the top n3 matches for this first picture. Okay, here we are applying the baseline matching on a specific region. Okay, we have to apply here on 9x9 square region. Okay, let's see how I have done it. Okay, the first I have selected the target image for comparison. After that, I have used the 9x9 square region in the middle of target image, and I have extracted it, which creating a very small image patch, and this patch will serve as the feature vector for the target image. After that, I have done feature comparison. The program then loops over a directory of images containing other images. Okay, for each image in the directory, the same feature extraction process is applied that will result in a feature vector for each image. After that, I have used the distance metric. Okay, here I will simply use the SD, that is the sum of square distance metric. Okay, after that, as I have computed the distance, then I will store it in an array. Okay, any array or vector. After that, I will sort it, and on the basis of the sorting on the ascending order, I will find the top n matches. Here I will find only top 3 matches. After that, I have done this histogram matching. Histogram matching, it is basically a technique that is used to compare images based on their color distribution. Okay, so in this task, I will be using single normalized color histogram as the feature vector for each image. Okay, the histogram, it will basically capture the frequency of color value in the image. Okay, so let me tell you how I have done it. I have first selected a target image for comparison. After that, I have calculated the color histogram for the target image. Okay, and then the histogram represents the distribution of color values in the image, right? So we used a normalized color histogram that considers the red colors RG chromaticity values, and then I have divided the range of color values into the bins and count the number of bins that falls into each bin, right? After that, I have done the feature comparison, and then I have used the distance metric, that histogram intersection distance metric. Okay, this histogram intersection, it will calculate the overlapping area between two histograms that will indicate their similarity. Okay, and then I have matched it, and then I have ranked it on the basis of top n matches. Okay, and for the multi-histogram, okay, here in this part, I have used 2 or more color histogram to represent different spatial parts of the image. Here each histogram will capture the color distribution of a specific region in the image. Okay, each region can be overlapping or it can be disjoint. To compare the similarity between images, we will again use the histogram intersection distance metric. As I told you, this metric will calculate the similarity between corresponding bins in two histograms. The higher will be the intersection value, the more similar the color distributions will be. We will also compute the histogram for other image in the data set, and then we will compare the histogram using histogram intersection, and then we will rank the image based on the similarity scores. After that, top n matches will be the image with highest similarity scores. These matches were obtained by using RGB histograms. So one will represent the top half and the other will represent the bottom half of the image. Okay, so each histogram will be has 8 bins for each RGB channel. After that, the distance between histograms, they were combined and using all the weighted average to determine the final similarity scores. After that, I have to find the texture and color. So for texture and color, first I will find the texture. Okay, and then I will find the texture and color. Here in this task, we are required to use both the color and the texture information to create a feature vector for image matching. This feature vector will consist of a whole image color histogram and a whole image texture histogram. Okay, so for the here, once I have calculated both the color and texture histogram for the target image, we can compare them with the histogram of other image in our data set using the distance metric. And here the distance metric should give equal weightage to both the color and the histogram and the texture histogram. This comparison will help us identify the top n images that are very similar to the target image in terms of color and texture. Okay, after that, I have used Gabor texture using Gabor filter. Okay, in this task we have performed texture and color feature extraction from an input image using Gabor filter and color histogram. Okay, so this will provide different level of feature granularity, ranging from entire image to smaller grid region. So first I have done Gabor texture. After that I have found Gabor texture and color. In Gabor texture I have first taken an input image and converted it to grayscale, and then I have applied a set of Gabor filter to that grayscale image. For each filtered image, I have calculated the mean and standard deviation, and then this standard deviation is stored into a 1D vector, forming the texture feature vector, and then I have normalized it using L2 normalization, and I have returned it. Same way, I have for Gabor texture and color, I have taken the input image, then using the Gabor texture function I have calculated the texture, then using the histogram function above I have calculated the color feature vector, and then the texture and color feature vectors are both concatenated into a single feature vector, and then I have returned it. Okay. Similarly, for multi-Gabor texture and color, I have taken the input image and then I have split it into a 2x2 grid. For each grid I have extracted its region of interest, and then I have calculated the feature vector for each region of interest using the Gabor texture and color function, and then the feature vector for all the grid cells are concatenated into a single feature vector, and then they are returned. Okay. So for one thing to remember, that for using Gabor filter we need to know about the Sobel X and Sobel Y, Sobel filters. In my previous video in the series of PRCV, I have told you about the Sobel X and Sobel Y. Okay, so now let's see the working of our project practically. Okay, so let's first go to our database. Here is our database. So first we have to extract the feature. Okay, we will come here and we will open this in terminal. First we will CMake. Okay, after the compilation is done, we will make to check if there are any errors. After make is done, it will generate two executables with the name image retriever and feature extractor. Okay, it is created in bin folder. We can see here are the two executables. Okay, first we have to extract the features. Okay, and it will take three inputs. The first is the path to the directory, second is the feature set, and third is the path to the CSV. Okay, so let's see, // we have to extract the features. It is in bin folder. Then / feature extractor. Okay, the first is the path. So this is our data set. We have to take the path. Now after path we have to write what are the feature set. B would represent the baseline feature set that we will be using. Okay, and then we have to enter the path of the CSV. For now I am entering feature.csv and I am creating it in bin only. Let's see. After it is done, let's go to bin and check if feature.csv is created or not. Yes, here feature.csv got created. When we will open it, it will show us all our picks. See, pick 0861 640 391. So my CSV is generated. After my CSV is generated, now it's turn for image retriever. Okay, so now for image retriever I will write image retriever. After that again I have to give the path of my target image, this time target image. Okay, which image I have to take? Let's see, pick dot 1016 pick dot 1016. Okay, after that let's see what is my second argument. So second argument is my feature set, and here I am using baseline as my feature set. So B. After that, my third argument is the path to the CSV, which is my features.csv. Okay, now fourth is my distance metric. Okay, so here I am using sum of square distance. So SD will be my feature vector. So sorry, distance metric. SD will be my distance metric, that is SD. And the fifth argument is my number of top n matches I want. Okay, so after it has finished reading, it is generating pic 0986, 0641, 0233. Let's see what are all these images. Let's go here. Let's go to the database and check. So we need pic 0986. Let's find. Control F, pic dot 0986. So this is my first match. Okay, it is same as this one. See, we took this image as our target image and it is showing this one, so it shows that our code is working. Let's see the second image, second top image. It was pic 0641, again 0641, and this is 0233. Pic 0233. So it shows that our code is working perfectly, our code is working fine. Let me take one more example with histogram matching. Now I'll go back again to my bin and I will delete my feature.csv file. Okay, and I will generate again. Here is my feature extractor, and instead of baseline, this time I will take HI, that is histogram matching. Okay. Oh, there is no feature type. Let me see what is the name of feature type. Okay, so it is C for color. Let me enter C. HI was a distance metric. Yes, C. It will take some time. Okay, so it is created. Let's see, let's go and check in the bin. Yes, here feature.csv got created. Now we have to retrieve the images. Okay, so this is our image retriever. Now let's see which image I have to check. Pic 0164, pic 0164, and I have to use histogram matching as my distance metric. So I have to make two changes. First, that is, instead of SD we'll use HI for distance metric as histogram matching, and here feature set will be C, and third is pic. Let me check again what is the pic number. Pic number is 0164, 0164, 0164. Now let's see. Okay, so it has generated pic 0092, 0898, 0110. Let's see. Okay, here these are all the pictures it has generated. Let's compare. See, pic 0092 is this one, which is here, the first one. After that it is giving, okay, 110, this one is the second, and the third picture it is generating some other picture, some random picture. Let's see if that image is closely matching to our image is not. It is pic 0898. Let's check that in database 0898. pic.0898. Yeah, we can see here this is also this also has green color in the center and blue here. Our original image has blue background. Our image also has blue background, so that's why it is showing it as a match. So this was all this is all for now. This was the project. There were so many feature sets. There were around 1 2 3 4 5 6 7 8 9 10 11 12. There are around 12 features set in this project. You all guys can type all the features set and check whether they are matching or not. You can take the code from my GitHub link. I'll provide it in the description below. And in the end, I would like to thank my Professor Bruce Maxwell, under whom I have done this project. So thank you very much and see you soon.